Hello, everybody, and welcome to Chapter 6. So today's lesson is on the page 335. Get ready. And I'm going to show you these questions as a review, and then you will take a short quiz on SavvasRealize about these questions. Okay, so here we go. Get ready. This is a review of transversals and parallel lines and all the angles that are formed. And what are their measures? So use the diagram at the right, find the measure of each angle. Justify your answer. So for number one, angle number one called corresponding angles. They're on the same side of the transversal and their sum is 180 degrees. So this one and this one, these two add up to 180. So that one would be 70 degrees. And the reason is corresponding angles. I'll just write corresponding. So this is 70. And then we have angle 2. These two are called linear pairs. And when they add up, when they make a straight line, when the two angles form a straight line, their sum is also 180. Also, you could say they are no, these are, wait, I made a mistake. These are not corresponding. They're called consecutive angles. Or sometimes they're called same side interior. Linear pair, sum is 180. So that one would also be 110. These two are called corresponding. Okay, and then we have angle 3. These two are called alternate interior angles, and they're they're congruent. So this one is also 70. And then angle 4. This one right here would be the same as this one. No, my brain isn't working right this morning. 4 and 70 are the same. Those are called corresponding angles. So that's also 70 degrees. Okay, and then we're talking about congruent parts. So congruent parts are the ones that are in the same location. Notice this is a triangle PAC, so I'm just going to draw it out. You don't really have to, but I'll call it however I please. But the second one is congruent to the second triangle, DHL. I'm putting it in the same order. Or you can just look at the way the letters are orientated. So PC, that's a segment or a leg. PC is a side, is congruent to DL, this side. This is an angle, angle H. This one is congruent to angle A. You can also look at your drawing, H, no, here we go, H and A. This is an angle, angle PCA. PCA, so that's this angle right here, is congruent to DLH, this angle. Or you can look at how it's listed here, PCA, DLH, has to be in the right order. This symbol means triangle HDL, so they just renamed it. They're calling it different now. So you have to look at the other triangle and follow the same order. H is in the middle, so I'm starting with A. D is the first, so that goes to P. And L is at the end. So that's how you name these correctly. It's called a congruent statement. And then we have triangle congruence. Remember, we have our choices was side, 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 side included angle, side, angle included side angle, and angle, angle, side. Those are the choices. You always want to mark what you know. I know these two angles are congruent. They're called vertical angles. So I have side angle, side, side angle, side. So these two triangles are congruent by side angle, side. Again, mark your vertical angles. I already got an angle here, so I have to make two bows. So I have angle, angle, side, angle, angle, side. And this one, I marked the side they have in common with 3 tick marks. So this one is by side, side, side. Midsegments of triangles. The midsegments are the, so if you look at the big triangle here, ACB, the midsegment starts at the midpoint of one side and goes to the midpoint of the other side. And these two are parallel. These two segments are parallel, and this midsegment is half the size of this side. Okay, so let's see, BC is 12. So this whole thing is 12 from here to here. What is BF? BF is half of it. Notice these two segments are equal, so BF is 6. And DE is half as well, that's 6 as well. So DE is half of BC. Okay, that's the relationship there. But we have 3 midsegments in this picture. So the next one is EF. Which one is that? They're looking at this and probably this. Same relationship. This is half of that. EF is 4.7. And then AD. Oh, from here to here. That's the same, 4.7. From here to here is the same as here to here. And AC, the whole thing is 4.7 plus 4.7. 9.4. Okay, so those were the midsegments and the relationship. And with these are parallel. This side is parallel to this midsegment, and it's twice as much as the midsegment. And there's 3 midsegments, so you have to kind of see which ones they're talking about. Looking ahead vocabulary, this chapter 6 is on similarity. And so an artist sketches a person. She's careful to draw the different parts of the person's body in proportion. What does proportion mean in this situation? Well, it means that the length, the measurements, they all look the same, but smaller, right? Measurements are smaller, but look kind of the same. So you don't have a big head and a small body. So the person in proportion when he draws her, yeah? Siblings often look similar to each other. How might 2 geometric figures be similar? So similar means that it has the same look, but different size. It's the same with proportion. A road map has a scale on it, tells you how many miles are equivalent to a distance of 1 inch on the map. How would you use the scale to estimate the distance between two cities on the map? Well, first you have to measure the distance on the map. And then you would multiply each inch. So you would say maybe 5 inches. Well, I don't know how much the distance would be, but you multiply your answer by the number of miles. So each inch would be a mile. And I'm going to write that like that. Let's say it's 5 inches, then that would mean it's 5 miles. Each inch equals 1 mile. So please go to SavvasRealize.com, sign in. In your class, you'll find a short quiz. We'll have 5 questions. It'll say get ready. I'll name the quiz Get Ready Chapter 6. There's another thing I would like you to look at, and this is on the page just opposite of Get Ready. So this would be page 334. And you're going to do this performance task. So I would like you to look at this kite. Charles is building a paper kite. He needs another dowel, which is like a wooden stick. To make a vertical support, so that type of support for the frame. So the wooden stick would go from here to here. He gives his friend Amy the measurements below, but neglects. So the measurements are 15 inches here. Remember, this is an isosceles triangle. So you want to kind of take this shape apart into its different parts. So look, the one I'm outlining right here is an isosceles triangle, right? And the same on the bottom. The bottom half or the bottom part is also an isosceles triangle. So everything we know about an isosceles triangle, you can apply here. But neglects to include the length of the support. So your job is to figure out this length from here to here. Yeah. So this makes this is perpendicular because the diagonals in a kite are perpendicular. So here's the clue I'm giving you. You got 1, 2, 3, 4 triangles here. They're all right triangles, correct? 1 right triangle, 2 right triangle. If this whole distance is 24, because it's an isosceles triangle, this line is perpendicular and it cuts these 2 segments in half, bisects them. So if this whole thing is 24, you now know how much is each part. So if you look at this right triangle here, then you already know 2 sides. How do you find the third side? It's called the Pythagorean theorem. A squared plus b squared is equal to c squared. To find all sides. And you're going to find this length, and then you're using the same clue here to find this length. And you would, of course, then what would you do with those two separate lengths? Right? Okay, these are the clues. Decompose into 4. Decomposing means take apart. 4 right triangles. Those are the clues I'm giving you. And use the Pythagorean theorem to find that missing length. Okay, so that's the first thing. Your job is to figure out from here to here, how far is it? What's this dowel? That's called a dowel that you have to cut to put on your kite. So that's the first question. You can work on this page and just show me your work. You got plenty of room right here, right? That is the first question. Find the length of the vertical support for this kite. And now here comes the second question, the area. So this is your first question. Here's your second. Find the area of the paper used to make the kite. Here are some thoughts. What is true about the diagonals of a kite? Perpendicular. That's how we get that 90-degree angle. How can you use this information to find the length of the vertical support? Right triangles. Use a squared plus b squared equals c squared. How can you find the kite's area? By decomposing the kite into smaller figures, 4 right triangles. And you would find each area and add them together. Now here's another clue. The area of a triangle is the base times the height divided by 2. And the base would be, this is your base, this is your height. Yeah, the base and the height are always perpendicular. And those are the clues I'm giving you. Good luck, everybody.